Okay, so let us start. Today we move to chapter 6 about data preparation. Okay, so there are three parts we are going to cover for data preparation. So data cleaning, data wrangling, and aggregation. In previous chapter, we cover some of it for each of the three sections, but we didn't do systematically and more detailed discussion. Okay, so in this chapter, we will discuss more about these three sections. First, let's get some idea about data preparation. Uh, Normally, when we get the data from various sources, the data are considered as raw data sets. Okay. So raw data sets, they may be large, like over here said, and also may be unstructured, and also may contain some errors, inconsistencies, and missing values. Okay. And for us to do data analysis, as what we have learned so far from previous chapters, and also for plotting in the last chapter, if the data got a certain number of errors, inconsistencies, missing values, and it's not going to be efficient to do those analysis. Okay, mm, so we need to do some preparation work for the raw data sets. Okay. So to pre-process raw data, then we can do data cleaning, data wrangling, and data aggregation. Okay. And for data cleaning, so cleaning, if you recall, previously we also learned a couple of functions like drop NA, okay, fill NA, like those related with data cleaning. So what it does is provide some solutions for missing values, duplicate values, inconsistent formatting, outliers, errors, inaccuracy, and incompleteness. Okay, and we will discuss the approaches to handle those in our example. For wrangling, wrangling is transform the raw data into a more structured format for analysis. Okay, so this is more regarding transformation. For data aggregation, it's to do categorization and summarization. Okay, using groups with certain specified criteria. And in previous chapter, we also learned some for the data aggregation. Same thing for data wrangling. Okay. So the first section is about data cleaning. Okay. So data cleaning, the very first step is you do some review for the raw data set. And if you recall, for data frame, we have some functions like describe, is not, like those, information, info, okay? So those can provide us some information about the raw data, okay? So from those, you can identify missing values and errors, inconsistencies. Okay, so after identification of missing values, errors, and inconsistent, then we can correct that. Okay, so that's regarding the general, the step is review, identify, and correct. Okay. And the task that can be done with data cleaning include identify and handle missing values. So missing value is one part, okay? Like is null function, okay, like a drop NA, fill NA, something like that. Convert data type or format into consistent types or formats, okay. And we will say like sometimes for numbers in the raw data set, it may be string format, but when we do analysis, we need it to be numeric type, okay. So we need to do the conversion, removing duplicate or irrelevant values, okay, and detecting outliers. So those are the tasks that can be done with data cleaning. Okay, and here it provides us about the data type for missing data, as well as some functions to identify and handle missing data. Okay, for data type for numeric, its representation is that NAM. We already saw that. Okay, so it's abbreviation, not a number. And for non-numeric, its representation is none. And for the functions to identify and handle missing data, so here we introduce some. And then in the previous chapter, we also learned, okay, so like the info one, okay, this will provide the number of null values in each column. Okay, so for each column, it provides some information for the column. Is null, so that function will return true for each cell, okay, like the row and a column, okay, if there is missing values. So it's depending on the argument, okay. Not null, so return true if there isn't missing values, okay. So we can use those to locate where the null value is, okay. And the drop NA, so it return only the non-null data and index values. So that's drop NA. And the fill NA, so fill the missing value with some specified values. So one of the most commonly used is to use mean value, okay. So those are some general functions that can be used for identify, handle missing data. And there are some other functions related with data cleaning, correct inconsistency in formatting dates, okay, for the dates. For the raw data, most of the cases for the date data, it's string format, okay, strings. And if you recall, when we use the datetime for indexing, normally we prefer to convert it to datetime type, datetime format. Okay, so there's a function in pandas called the toDatetime, and we previously also saw the example. Okay, so that's one thing that we can format dates. Okay, and also make it consistency. And there is another one to format data, format data as a certain format, like over here, like it shows, okay, year, month, and day, okay, in certain format. You can also call this function, okay, string app time, okay. And if you recall, we also learned in the previous chapter, in plotting, and if you recall, we format the axis, okay, using this function for the plotting axis as a label, okay. So that's for the formatting dates. The next one is about identify inconsistency, okay. So for number, is it because some number system use comma instead of decimal, is it? So we needed to make it consistency when we do analysis. And some have leading and trailing spaces in numbers, okay? So how to handle those? So one approach is to use string manipulation methods or regex. And regex we discussed in chapter 1, okay? And one of the functions that are commonly used to do replacement is called the replace. Okay, so you can specify the string, the subsection of the string, and replace it with some new specified string subsection. Okay. So that's the replace, so regex. And another one is to convert a string. So the number formatted in string. Normally raw data, even though you have number, normally they are considered as a string. Okay. So then in that case, you can do the conversion, use to numeric to convert from string format to numeric data type so that we can do some analysis. Okay, especially later on we will see when we learn the modeling. Okay, modeling can only deal with numeric data. Okay. And to remove some extra spaces in texts. So the strip function, you can use that to achieve the goal. And some other text standardization using string manipulation or regex, okay, from chapter 1. Outliers. And if you recall, in data frame, we have the describe method. Describe method that describe minimum to maximum, and in between we have 25 percentage quantile, 50 percentage quantile, 75 percentage quantile. Okay. And that quantile concept, we also cover that in plotting for box plotting, if you recall. Okay. And a box and a whisker, if you recall, is it? Yeah. So in box plotting, it also shows outliers, is it? So outliers, you can use describe the quantile, and then you can remove outliers, like use NumPy, the clip method. Okay, you can remove it. So that's some conversion and formatting, okay, for data cleaning techniques. And the next one is to discuss data wrangling, the concept, okay. So data wrangling is that it involves data transformation. So it's transformation. Then, if you recall, previously we discussed reshaping data. Is it? If you recall, we make the data frame from wide to long, and or from long to wide. Is it? So reshaping. Okay. Add new features. Okay. So that's transform and the feature scaling. Okay. That's also transformation, and also combine data from various sources. If you recall, we discussed is that you can concatenate multiple data frames together, can merge them, can join them. Okay, so those are considered as transformation. And also you can encoding categorical data, okay, for analysis. So we will see in our example, okay, what is categorical data, okay. And to transform categorical data into numerical, okay, because for analysis, especially for modeling, it only take numbers. So you needed to convert, transform categorical data into numbers, okay. We can use technique like indicator variables or one-hot encoding, okay, we will see that. So one-hot encoding, so what is one-hot encoding? It says one-hot encoding is create new binary variables. So only 0 or 1 for each category, okay, except for a chosen reference category. Then it says this new variable indicate whether a data point belongs to a specific category. Okay, we will see that in our example. To do the one-hot encoding, we will introduce two approaches. Okay, one is use the pandas library. The other one is use a machine learning package library. Okay. And for pandas, you can use get dummies. Okay. And I remember previously we also discussed the get dummies. So we will review that. Okay, and more discussion about data wrangling. Uh, is combine data from various, we already did encoding category data. Yeah, we already discussed this. And for data reshaping, if you recall, we introduced in chapter 4. Okay. So pivoting, melting. If you recall, for melting, it's to get the data frame from wide to long. Okay. And especially for seaborn plotting, we use melt a lot of time first, okay, because the seaborn prefer the data frame to be the long format, okay, stacking and stacking, if you recall. And this is also regarding multi-index, hierarchical index, is it? So it says that's why data reshaping often involves working with hierarchical index or multi-index. Okay, so this is a concept for data wrangling. So for the concept part, we are going to stop here for data wrangling. And for the aggregation, we are going to cover in our next class. Next, let's see our example. Okay. So for the example, so this example is in our textbook. And you can also find the complete code in the GitHub. Okay, it's a textbook's GitHub. And for the first part, for data preparation, we use a data set from World Bank. Okay, and the World Bank is it's very interesting, and I encourage you, if you have time, want to play around with data analysis. There are a lot of data sets here. Okay, for the World Bank. Okay, so you can go to this website. So there are a number of data sets available, falling into different category. Okay, you can see. Like this is WBG Finance. Well, okay, we can also take a look. Some energy data. Okay, so quite a number of data sets. Okay. And then first, let's take a look at that WBG Finance, is it? And so it's a public financial data with Finance One, okay? And we can get comprehensive information on financial results, okay? Procurement, lending, and some more, okay? And so if you are in business major, maybe you understand the concept. But there are quite a number of data sets that we can use. And you can see it also provides the analysis result, is it? So if you get the data set and if you can try, okay, like what here already provided, to see if you can get the same result, is it? And it has the data sets. Is it other data set, financial reporting, loans, credits? Okay, so all sorts of data sets. So this is a public available data sets. Okay, so you can see basically in data analysis. In machine learning, the AI field. So data is very, very important, okay, to get the data. And For the WB data, the World Bank data, in Python, they also have a package. Okay. And here is the package is called WB data. Okay. So in our example, I use this, and you first need to install it. Okay. After you install the WB data, then you can go ahead to use it. And it has different category, and you can specify the category and and then you see you specify the category that and then you can get the data and then do some analysis, and this is a documentation for the WB data. Okay, so in case you're interested, you can refer to this website. So we are going to use the WB data. Okay, so I follow that to do the installation. And after you install, then you can go ahead to import the WB data. Okay, so you need to import this package in order to use it. So what we did is we are going to retrieve the official exchange rate, okay, from the World Bank data. And we also specify the date range. So starting date and ending date. Okay, so between January 2020 to 2024. Okay. And after that, then you can, because we already specify the exchange, so you can directly call the get data frame and plug in whatever indicator, then it will return you a data frame. And with the data frame, you can also save it to a CSV file. For this case, because once you have CSV file, then the data is local. So that you don't need to download it each time. It's more convenient if you want to work it for a period of time, save it to a local file. And then let's take a look what the data looks like. So then you can do the header, okay, to see the top 5 records. Let's see what it looks like. Okay. So here is what it looks like. So it's not a lot of columns. Okay. So it has country, have date, and the exchange rate. And we can also see for the first 5, the exchange rate are all missing values. So that's why this data set is a good example to do data cleaning. Okay. And here we call the reset index. Okay, so reset index, then here is to have both the date and the country as columns here. Okay. So this is what a reset index does. And after that, if you recall the date column, so the date column in the raw data, generally speaking, it's a string. So here we want to change it to datetime format. Then you can call this pandas to datetime to convert it. Okay, convert this column to datetime format. Because after you convert to datetime format, then you can use it to specify the range. Okay, you can say, okay, it's filter the data between the starting date and the ending date. Okay, so you can specify the range using the comparison, as it and the end condition. Okay, to do the filtering. And after that, we can check again, okay, about the data. So let's see. So now this is what the data look like. Okay, yeah, you can see there's some difference, is it because the date range specified, not like here 2019 not included, because It started at 2020, is it? Yeah. So it will meet our requirement. Okay. We did the filtering. And then next, we try to check about missing values. So you can use that is null function. Okay. After you do is null, you want to do the summation to find the total number. So you can call the sum function. And then let's see how many we have, the missing values. The missing values, if you see country for each column, it will tell you. So country, we don't have any missing value. For date, we also don't have. But for the official exchange rate, yeah, we have quite a lot. We have 261, okay, rows for the missing values. And because of the missing values, you can perform the drop NA, okay? So it will drop off the missing values. And after that, we can check again, okay, to see if it did drop the missing values. And you see, after we do the drop NA, then you see the exchange rate doesn't have any null values. Yeah, so it did get taken care of. So that's regarding is not and the drop NA, okay. And the next, let's see. So a lot of times we also want to make your data consistency. So it deals with like some string processing. So over here for the country column, okay. For the country column, so we want to do something to remove some extra spaces in the country name. So what you can do is for that specific column, so here you use a dot lock, okay, and specify the column name. And then you do the .str, the string, and the strings function strip. Then it will remove extra spaces in country names, okay. And what the next one is, we can also, if you recall, is it some of the numbers, it has comma in it. When we do analysis, especially modeling, we cannot handle that. Is it? So you need to remove that. So to remove that, over here is you find the column. So this is use dot lock to find the column. And to make it consistency, we also convert it to string type, okay? And then you can call strings replace function. You're going to replace the comma and with nothing. So basically, you just remove the comma, okay? So this is to remove a comma from your string. And then next, after it's get cleaned, and we want to change it to numeric format. So in order to do that, you can call the toNumeric function, okay? And here, you also have this flag, arrows set to cores, okay? So what does this mean? This means the cores handle some situation when some value cannot be converted to numbers. Yeah, that can happen, okay, in the raw data. So we need to take care. Then in this case, we will replace that value with a nav value, okay? So that's what this part does, okay? And what next try to show is to get some information about the duplicate value, okay? To find how many we have. And we can take a look. The duplicate, there is 0, okay? So no duplicate. So no duplicate. And if you do have duplicate, you can also call the drop duplicate function to remove that. Okay, the next discussion is about the outliers. And if you recall, so here regarding the outliers, we related with quantile. Okay, and if you recall, in box plotting, we discussed the quantile as a 25% quantile and 75% quantile, and the median is 50% quantile, as it. And we also have the 1.5 IQR, is it, and the 1.5 IQR for the upper and lower band, and then outside of it are outliers. So that's the first time we get the concept about the quantile. Okay, so here you can also specifically get the quantile values, use the quantile function, specify the percentage, 25%, 75%. So once you get that, you can calculate the IQR. Okay. Once you find the I, so that's the difference between Q3 and Q1. Okay. Then you can find the lower bound is the first quantile minus 1.5 IQR. Upper bound is Q3 plus 1.5 IQR. So this is regarding the quantile. So once you have the quantile, and to define the outliers, they are lower even than lower bound, or even higher than upper bound. Okay, those are considered outliers. Okay, so we can output of those outliers. So let's take a look. Outliers over here. Yeah, and outlier, there are quite a number of outliers, 166 outliers. And it lists all of the outliers, okay, based on the quantile that we define. Okay, that's regarding outliers. And after that, we are going to show the cleaned data again, okay? So you can call the data head. And you can also, generally speaking, can also write the cleaned data back to the CSV file, okay? So let's see. Yeah, so this is a cleaned data, okay? Okay, so that's the first example is about World Bank data, okay? Do the data cleaning. And before we move to data wrangling, I also provided a supplemental example. And for this supplemental example, it's not in the textbook, okay, but there are just some other nice options that we can use to do data cleaning and wrangling. So let's go ahead and take a look, okay. And before we move to data cleaning, so data preparation, there is one statement that's also may be useful, okay, when you do the coding. So it's called the set option, okay, and you set future no silent downcasting. So what this do is it to prepare code for future updates, okay, so that the code remain compatible with new edition, okay, with new version, okay, so that make code more robust and less likely to break when pandas updates, okay. So you can borrow this. Okay. So the first one, so this is a dictionary. So we already know, okay. With this dictionary, you can directly call the data frame to create the data frame. And we can see in the original one, we have some missing data there. Is it? So it's going to replace that with the nav values. So now the data frame looks like this. So this is the data frame. So it has two nav values on column C and column D. Okay. And if you recall previously, we said you can use it is now. As it. So is now and then do the summation to find the total for each column. So this is for each column, how many the nav values. And for data frame, you can also call the values, okay, to get the data frame values part. And to do the data cleaning for missing value, you can call the drop NA function. Okay, for drop NA, you can specify which axis, along row or along column. If axis is 0, then you're going to remove the row that has the nav values. So you see, we remove both the last two rows. But be careful, okay, the drop NA, when it return a new data frame. The original data frame not impacted because here we didn't specify that in place is true. So it won't impact the original one. So if you do want to change the original one, then you need to set that impact. Now that in place, okay, flag. So keep that in mind. So it doesn't impact the original. And for drop NA, you can also specify along the column. So then you see, we keep A and B column, but C and D column are removed. There are some other arguments that you can pass with drop NA. You can specify with a how. Okay, so how over here it's said or, not any. You can also specify any. If it is a how, if it is or, that means the whole column or whole row needed to be null. Then you remove it. Okay, you drop it. And for this case, because none of the row or column. So basically it wouldn't remove any column, okay? And you can also specify the threshold, the thresh. So in this case, that means you will drop the rows that have less than 3 real values. Okay, less than 3. So that's why row 1 and row 2 both are dropped. And you can also specify the subset. Okay, so what this idea is that says only drop rows will then appear in a specific column. So here you specify the subset is C. Okay, so only when that appears in this specific column, then you're going to drop that row. Otherwise, you're not going. Okay, so that's why D you can see it's not impacted. That's why the row 2 is not impacted. So the above is about data cleaning. And for data cleaning, there is another library that we can also use. Okay, it's from this sklearn, so scikit-learn, okay, package. So scikit-learn is the package is for classic machine learning, okay, models. So it contains a number of machine learning models that we can just go ahead to use. And because for machine learning, it also needs to use data frame, okay, data sets. So that's why sklearn library also include some data pre-processing packages that we can go ahead to use. So the first one we here learn is called impute, the simple imputer, okay, class. So what it does is that it will impute missing values via the column mean, okay, using column mean to impute missing values. So how do we do it is you first create an object of simple imputer, okay. You specify what the missing value look like, okay. How you're going to fill it. Here, the strategy mean means you are going to use column mean values to fill the missing values. Then you call the fit function and plug in with the data frame's values. And then you transform the data frame's values. So now you can get the imputed data. So this item and this item, these two items, previously they are not NaN values, but now they are updated with the mean of the column, okay, mean of the column. So they are filled, okay. So this is what this simple imputer can do, okay. So that you don't need to do one by one calculation, it will take care. You just call the function, call the respective fit and transform function, so it will automatically handle all of the missing ones for us. This is very useful when your data set is large, okay. Yeah, next, let's see. So here we have lists, okay, three lists. Basically, it's kind of like a two-dimensional, is that? And then here are the list for the column names. Okay, and then the data frame then looks like this. So you see, for color, it's all string. Size also string. Only price is numeric. Is it class label? It's also string. Okay. Generally speaking, like in machine learning, these three columns we call them feature columns. And the last one, the class label, we call it target column. So normally feature represent as X and target represent as Y, okay? And you can use feature columns and to train some model and then use a model to predict the target value when a new set of feature coming in. Okay, so that's the idea about machine learning. So anyway, so here you see we have two columns. Basically, over here, three columns of data, they are not numeric. So how do we convert them to numeric when you want to do machine learning? Yeah, so let's see. So we first, for the size, okay, t-shirt size, we can define a dictionary, okay? And with the dictionary, then you can call the map function. Okay, and if you recall, we learned a couple of functions that can apply either element-wise or column or row-wise, okay, to do some customization, customized function call on the data frame. So map is one of it, and only map will accept dictionary, okay. Another ones like apply, if you recall, is it an apply map. something, and transform. So those can be provided so it will take in customized functions, okay, either element-wise or row and column-wise. So anyway, so after the size dictionary, is it if you take a look the size column, so now size column is also numeric, okay. So this is one approach that's also used a lot. If your data set is not too complicated. And for dictionary, you can also reverse the key value pair. To do it is the item return key value pair, is it? So here we use dictionary comprehension, is it? So this is the loop, and within each loop, you are going to reverse key and value pair, is it? And after, so basically value changed to converted to key and key converted to value, okay? So then you can do the map function again and provided this inverse mapping, okay? Then in this case, you will get the respective categorical data as MLXL, okay? And what next? Try to show, okay, over here. So this is about the class label column, the last column. The last column, they have different label, like class 1, class 2, class 3, something, is it? So you wanted to know how many unique classes they have. So you can call this unique function. And we can also enumerate it so that you will get the ID and its label, okay? And after that, you can reverse it. So this is another dictionary comprehension, okay, to create a dictionary comprehension. And then you see that's the result. And with the class label, if you call the map function for the specified column, is it? So you are going to get the numeric numbers, okay, for the column. And we can also do the inverse mapping, if you recall, okay? And you can call map to update that column. So now it's changed back to the categorical data, okay? Okay, then next, let's take a look. Here we have a new class called label encoder, and this is also from scikit-learn, okay, and from its data pre-processing package, the sub-package basically from scikit-learn, okay. And if we want to do it, you first need to create a label encoder object. So after it, you can call fit transfer and provide the specific column, okay? Then it will convert it. Yeah, so you see, this time you don't need to do that unique and then do the dictionary creation as it. So you can just directly go ahead and use scikit-learn's label encoder to achieve the same goal, okay? And you can call the inverse transform. So it's much convenient, especially for larger data set, okay? So what next we will get? We will only get a color size, and price. Those three columns, okay, from the data frame. And we give it to a variable X. And then we do label encoder, okay, for the first color. The first color is color. So we are going to do, to convert it to numerical value with label encoder. So after that, you can call fit transfer, okay? And then you see, this is a result of label encoder. So it automatically take care of that. So keep that in mind. Label encoder is one approach, okay? And the dictionary mapping is another one we already see. So see, we have this data frame. So this is our data frame. And this is the subsection of the data frame, okay? So including color, size, and price. And then what next one we are going to see is, so here we deal with one-hot encoder and ordinal encoder. So both of these are used for categorical data. So categorical data like the t-shirt size, color, okay, they are all categorical data. And there are two types of categorical data, okay. One is nominal and one is ordinal. So nominal doesn't have order. Ordinal doesn't have order, okay, like for the size. It's ordinal. It's M, L, and XL. For nominal, there is no order, okay? So like the color, it's nominal, okay? And we can use different approaches to convert categorical data for nominal and ordinal, okay? So let's take a look. And here we are also going to use a column transformer, okay, from the compose package to do the rearrange, kind of reshaping. Oh, this is not reshaping. This is adding new features, adding new columns, using one-hot encoder, okay, and also using ordinal encoder. So let's see, how do we do that? Okay. So for the first column, color, we are going to use one-hot encoder. For the second column, the t-shirt size, we are going to use ordinal encoder. Okay. For the remaining, what we are going to do is for the remaining, what we are going to do is we just let them pass through. Okay. So to do that, we also use scikit-learn compose subpackages column transformer, okay, using this class. And within this class, you define the transformer. So the transformer here, we have two transformer. One is one hot. So this one hot encoding will be used for nominal data, okay? So in order to do that, you create one hot encoder, okay? You also provide which column is going to be used for one hot encoder, okay? And for ordinal, then you need to specify the category, okay? And then provide the column. So remainder is all of the remaining columns. They are going to pass through. So after you define the column transformer, then you can call the fit transform function, okay? With the fit transform function, then the one-hot encoder and the ordinal encoder will function, okay? And we can see the data. So if you take a look, it's kind of weird because the origin column only have the original data frame. So original data frame only has 3 columns. If you recall, it's color, size, and the price. Okay, so let's see, last column, price, looks right. And this is for size. Yeah, so size is ordinal. Okay, ordinal means it itself, the categorical data itself inherently has order. Okay, like M, L, and XL. Yeah, they have order, is it? But for color like red, green, blue, it doesn't have any order. So that's why we call them nominal data. Okay, so yeah, so this is for size converted. But then over here, you see, for the color, we have 3 new color. Okay, so if you recall, then we call this one-hot encoder. So for one-hot encoder is what it does is because it is categorical and nominal, and so here basically we have 3 categories: red, green, and blue. Is it? So if you remember, one-hot encoder is binary, 0 or 1. Is it? Yeah. So then basically it will convert it to like color red, color green, and color blue. It will create this 3 new color. Okay. So if it's red, then it's 1, otherwise 0. So same thing. If it's green, it's 1, otherwise 0. If it's blue, it's 1, otherwise 0. Okay. So it get expanded from one column to 3 column. The 3 column is corresponding to each category. And the data is going to be either 0 or 1. Okay. So this concept is called one-hot encoder. Okay. So then in this case, okay, you can see, yeah, if it is that category, it will be 1, otherwise or 0. Okay. So that's the idea about one-hot encoder. And then let's see, so that one-hot encoder is, and the ordinal is from scikit-learn package, okay. And you can also convert the nominal data using get dummies, okay, nominal data. So here, let's take a look. So for the size, we use dictionary to map, okay. And for color, if you want to use get dummy, you first need to convert it to categorical data, okay? And after that, you can call get dummies, okay? Yeah, after you call get dummies and convert it to integer, so here is the result looks like. That's what the result look like. You see, from original 1 column, now you have 3 column. Okay, 3 column. So if it is blue, then it's 1, otherwise all 0. So if it's green, then it's 1, otherwise all 0. If it's red, it's 1, otherwise all 0, okay? So that's the idea called one heart encoder, okay? And for get dummy, to prevent like collinear, is it? You can also drop the first. So drop the first is, in this case, for the blue, we can drop it. Because you see, for green, okay, it's 1. For red, it's 1. For the third row, both are 0. So inherently, that means the third row is blue color, even though we don't have that color blue, but inherently it indicates that's a blue color. Okay. Okay, so this is regarding the additional, the supplemental example for cleaning and wrangling. Okay, so let's go back to our textbook example. Okay. So this time we are going to do the stock data again. We're going to use Tesla data. Okay, we also specify the starting and ending date. Okay, then you can call the Yahoo download. So what here we are going to calculate 5-day moving average. So to do it, you call data frames rolling function and specify how many days you want to roll. Okay. And you need to aggregate. So here we use a 5-day moving average as mean value. And after that, we can define 2 columns above moving average and below moving average. Okay. So if the closing price is above moving average, then you define it as above moving average, and you convert it to type, okay, to integer type. Same thing. If moving average is, this is below, is above, then you also convert it to integer. After that, we add this 2 as the new columns for the data frame. Okay, we can take a look at the top 10 records. So here's what the top 10. So now it has the moving average column. And for the moving average, if you see, it also has the above moving average and the below average moving average. Okay, there's 2 new columns. Okay. And what the next one try to show is the percentage change, okay, for this function apply to the data frames column, okay. And if you want to know the daily return, if it's positive or negative, and then you can use the percentage change greater than 0 or less than 0, okay, to do the tracking. So now with this 3 new column, you see it provide us with the information. So this 2, and as well as the above part for the moving average, is that this kind of like the dummy column, okay, because it only has the values of 0 and 1. Okay, then next, let's see. So this time we still get Tesla's data, and we are going to use its adjusted closing price percentage change. Okay. And here we use pandas cut function. If you recall, cut provide you categorical data. Okay. And it depends on how many bins you can provide. And here we only have 2 bins. Okay. From the negative infinity to 0 and from 0 to positive infinity. We only have these two beings. And these two beings labeled as down and up. Okay. Right true means you want to be included. The rightmost edge be included in the beam. Okay. So it's going to cut the daily return, okay, into these two beings, so positive or negative value, okay. And after that, you can call the get dummy functions, okay, for this new color movement, okay. And you can set the prefix, okay, the prefix as because it's categorical with up and down, is it? So you can prefix it with movement, okay. The drop first set to true or false. So drop first set to false means it's create dummy variable for every category. Okay. If it's set to true, then drops one category. Okay. If you recall previously, we also learned. Okay. Yeah. So that to avoid collinearity. Okay. To reduce the dimensionality. So that's the idea for the get dummy with categorical data this time. Okay. And then we concatenate them together as it along the column. Okay. So we are going to basically add more column. And after that, if you take a look, because you see the movement column, the data is categorical, is it either up or down, okay? And because it's up and down, so that's why this two column is because of the get dummies, okay? And you prefix it with the, so this is a prefix part. And the value will only be either 0 and 1, okay? But they are from the respective value from the movement. And because they are nominal, is it? So you can use the get dummy to achieve. This is one hot encoder again. Okay, but use pandas, get dummy to achieve that. Next, let's take a quick look at hierarchical index. And in previous chapter, we also learned, okay, hierarchical or multi-index. Okay, so here we have three ticker, Apple, Microsoft, and Google. We also specify the date range. Then you call the download, Yahoo Finance, okay. And let's take a look at the top three records. So what the data looks like, if you take a look, is it the outer column is regarding the price, just close, and volume, okay. The inner one is the ticker, okay. Okay, then with this multi-index data frame, if we do the stack, so this is a quite wide data frame, okay. If you call stack and specify the level, okay, it will make the original change it to long format. Okay, yeah, and then you can specify the hierarchical index. So here we set date and ticker, okay. And then let's take a look after you call stack, what it achieves. And so here, this is a shape transformation. So this is belong to data wrangling. So the reshaped data, you see, yeah. So initially ticker is it, so this is level one. Okay, so the inner level from column change it to index. Okay, change it to index. So make it longer. Okay, so this is shape, reshaping. So reshaping basically it's transformation. So data set transformation then it belongs to data wrangling. So you can use a stack, unstack to reshape the data frame. And what the next one is also a new concept. Okay. For multi-index, if you recall, to select the data, previously we learned that XS. So XS is cross-section selection. Okay, cross-section selection. And if you use XS for the following one, then you can specify, okay, the XS specify the level, okay, the ticker and the level. Okay, that's for the cross section. And over here, we use the dot lock. Okay, previously when we learned dot lock, we didn't provide any of the hierarchical index example. But this time, you see, you can do this. You can use a tuple for that axis. Okay, and for this tuple, then this means the first level, and this is the second level. Okay, so date and the ticker apple you select. Okay, and then we can take a look at the result. So that's the result look like. Okay, because that slice now in the and then you have that AAPL in a tuple. Okay. Uh, so in a tuple, so you first that's slice now. That's corresponding to the first level, and then this represent for the ticker level. Okay, so you can specify the specific level for multi-index, then to retrieve all of the respective values. Okay. So this also shows how do we do the data wrangling. Okay. Okay, so today we covered data cleaning and data wrangling. Okay, and the next class we are going to cover the data aggregation. Okay, so I'm going to stop recording.